Welcome back to the Python series. In this video, we are going to discuss about operators in Python. What are operators? Operators are nothing but special symbols. And why do we need operators? Operators are used to perform operations on variables and values. And now, operators in Python are classified into 8 different types. They are arithmetic operators, assignment operators, relational operators, logical operators, identity operators, membership operators, unary operators, and then bitwise operators. So let's start with arithmetic operators. So first let's create a new Python file. Operator. In general, we have only 4 arithmetic operators: addition, subtraction, multiplication, and then division. But while coming to the programming, we just don't have those 4. We also have some more functions or operators. So let's see them. And now we can also directly assign the values to the variables in a single line by placing a comma. This will tell that the value of A is 11 and then the value of B is 3. These are the 4 arithmetic operators that we have learned from the childhood. So let's run this. Here we can see we got the outputs. And now let's discuss about some other arithmetic operators. The very first one is floor. This will give the floor division. Let's run this. Floor division will round the quotient to the nearest and largest value. For this, if you just make this -3, and now let's run this again. Here we can see we got -4. Dividing 11 by -3 will give the quotient of -3.66666, so that the largest value which is less than or equal to this quotient is -4. So let's start with another operator. This symbol is equal to raised to the power, that is, it will give 2 power 3. Let's run this. Here we can see it gave 8, that is 2 raised to power 3. And then other operator is that modulus operator. Modulus operator generally gives the remainder of a division. Let's take three. So let's run this. Here we can see we got 2. While we divide 11 by 3, we will get the remainder as 2, right? And for modulus operators, we have some limitations. So let's see them. Just change this as 12. Now run this. Here we can see we got 11. And why we got 11? The condition is that if the denominator is greater than numerator, then modulus operator will return the numerator itself. So now let's see what happens if you take negative values in modulus. Let's take it as -3. So let's run this. Here we got -1. So let's remove this and then let's do it here. Minus. Let's copy the statement. Let's run this. We got 1. We got -1 in the last one, but 1 in this situation. But why? What is the problem? The main problem with modulus operator starts when we use negative numbers. Actually, to solve this, we need to know the actual formula behind modulus operator, and that is generally remainder equals to A modulus B. The formula behind modulus is that A mod B is equals to A minus floor of A by B multiplied by B. This is the formula followed while calculating the modulus operator. Floor of A by B is nothing but floor division, the value after performing the floor division of A by B. Now let's try this. Here A is -11 and then floor of -11 by 3. For this we have a built-in function. For this we have to first import a library. To import any library we have to use the keyword import, and then we have to give the library name math. Print of math dot, we have floor of -11 divided by 3. So let's run this. Got -4. So let's see this. -11 minus of -4 multiplied by 3. So that will give -11 plus 12. Here multiplication should be given the first preference, so that it will give -11 plus 12, so that equals to 1. So in this manner modulus is generally calculated. It can be done. Now let's see for the previous one, -3 and then 11. So let's comment this and then comment this. So let's run this. We got -1, right? A mod B. So let's figure it out by using this formula. Let's run this. We got the same. So let's take here A is 11 and then minus of floor is -4 multiplied by -3. So this will give 11 minus of 12, that equals to -1. So like this modulus operator works. And now let's move on to the next operator, that is assignment operator. Assignment operator is generally used to assign values to the variables. So let's take an example. X is equal to 6, and now equal to is used to assign value in assignment operators. And now what if I want to increment the x value by 2 so that it becomes 8? To increment x plus 2. To increment x by 2, we have to place generally x plus 2. Then x has to be modified as 8. If you just add x2 to the x, then x becomes 8, right? So that we have to place x equals to. So now let's print x. Now run this. Here we can see we got 8. Generally, to add 2 to the x, we wrote this statement, and then after adding 2, x will be modified with the result of this statement, so that we gave x here. And this operation can be done in a shortcut way, that is by placing x plus equals to 2. It is same as the above one. We can also test it. First let's remove this. So let's run this. Here we can see we got x is 6 and then x plus equals to 2 is 8. Likewise, we can also do subtraction, multiplication, division, floor division in the same way. For that also we have the same shortcuts. To subtract, we can give minus here, and then to do division, we can give divided by here, and then the number which should divide x should be given here, that is 2 or 3 as your wish. So let's see the example, does it work or not. Here x is 6 and we divide it by 2, so we have to get 3.0. Here it worked. We can also do floor division. So let's run this. We got 3. X equals to 2. So let's run this. After doing floor division, we got 3, and then 3 raised to power 2, that is 9. So let's move to relational operators. Generally, relational operators are used to compare two values or then two variables. So let's see this. Double equal to symbol is used to check whether both the values are equal or not, whereas single equal to is used to assign the value. So let's run this. Here we can see we got boolean value false, as A and B are not equal. And then how can we just see greater than or equal to? For this, in general way, A greater than or equals to B. Greater than or equal to is written with this symbol, greater than and then equal to symbol. So let's run this. Here we see we got true, and we can also find whether two values are not equal or not. So let's see. For this, let's take A. To ask whether it's not equal to, we have to give an exclamatory mark and then equal to symbol and then another element. So let's run this. As the A and B are different, so it gave true. So let's clear this and run this. For less than, we can use less than symbol, and then for less than or equal to, we can use less than and then equal to symbol, and then for greater than, we can use greater than symbol, and that's with relational operators. And now let's move to unary operators. Unary operators are operators that generally work on single operand or single variable or single value. So now let's see unary operators. For this, let's take x equals to 6. And now what if I want to negate it? Then we can give x space equals to minus x. Now let's print x. So let's run this. Here we can see we got minus 6. So by using unary operators, we can give a negation to the existing one. So that's about unary operators.